Hello, class 12th students. Today we are discussing the this chapter 5 NCERT book, that size number 5.4. This is differentiate the following with respect to x. E raised to x sine x. I want to differentiate this function is that with respect to x. You say dy dx of ex equal to what? Same function ex. This is the exponential function. His differentiation is same. And the sinus function is that, also that dy dx of sin x will be equal to what? Cos x. Okay. You know these two formula very well. So what I'm saying that here, this is quotient forms are there. There's a numerator function. We have a this is rational function. UV cos is there. So we apply the UV formula of differentiation. Dy dx of UV will be equal to UV minus UV divided by V square. U dash V minus UV dash. So here the EX is a U and sinus is V. Now we differentiate this function. If we differentiate this function with respect to x, I write down EX, differentiation of EX, that will come out EX. Keep the V sinus as it is, minus keep the U, that is here the EX as it is, and differentiation of sin x, that is cos x divided by sine square x. Say numerator, you see this one, the ex is common. Take the ex common, you are getting sin x minus cos x divided by sine square x. This is the answer of this question. Now, question number 2. E raised to sine inverse x. I would like to differentiate this function. So this one is differentiated by this, we say dy dx of e raised to sine inverse x. Okay. So this will comes out if you differentiate this one. E raised to same function. Write on the same function without any doubt because e raised to x is there. Now this is not the x basically. This is a sine inverse x is there. Okay. So I have to differentiate this function again. See dy dx into dy dx of this part sine inverse x. So we write down here the e raised to sine inverse x into 1 upon under root 1 minus x square. This is the answer differentiation of e raised to sine inverse x. Now, question number 3. E raised to x cube. I want to differentiate this function. Dy dx of e raised to x, and x also has a power 3, e raised to x cube. So we do the differentiation. We are getting the same function. First we write on the same function. Now you see this is not the x, this is the x cube. So differentiation of this part x cube. So what we are getting? E raised to x cube into 3x square. This is the answer for this differentiation of e raised to x cube. Now, question number 4. Sine tan inverse e raised to minus x. Say here the many steps are there. First, sine function, differentiation of sine. You know the differentiation of tan inverse and e raised to minus x are there. So dy dx of, we say here, sine tan inverse e raised to minus x. First we write down the cos of this whole function, tan inverse, and you see this e raised to minus x is the angle of this function tan inverse x, not the angle, is the value. Now into dy dx of this part. This is because this is not x. You see it here, tan inverse e raised to minus x. So the first terms we write down as it is, cos tan inverse e raised to minus x into differentiation of this part. So tan inverse is there, we say the 1 upon 1 plus e raised to minus x whole square into. But again, you see this part e raised to minus x is not x. So we have to do the differentiation of this part again, dy dx of e raised to minus x. Now this will comes out cos tan inverse e raised to minus x into 1 upon 1 plus e raised to minus x whole square can be written as e raised to minus x into 2. X into 2 means minus 2x. And this one, e raised to minus x and minus 1. This is not x, minus x is there. So again, you can say minus 1 comes out. So you may write down, fill up all the things and write down the answer in this way, minus cos tan inverse e raised to minus x into e raised to minus x divided by 1 plus e raised to minus 2x. This is the answer for this question. Now, we want to do this question number 5. We want to differentiate this function with respect to x. So see, differentiation of this function, dy dx of log is there. I will write down ln log cos function cos e raised to x. If we differentiate this function, let's say we are getting log function is that 1 upon cos, this is the angle basically, you can say cos e raised to x. Since this is not x, so this is also differentiated, dy dx of that part cos e raised to x. So now in the next line, we write down the function 1 upon cos e raised to x, and we differentiate this part. Cos becomes a minus sine e raised to x. But again, you see this one, this e raised to x, it's not the angle, x is there. So this is again differentiated, dy dx of e raised to x. So now this becomes minus sign taken outside. You see sine e raised to x upon cos e raised to x into differentiation of this part, dy dx of ex will give you ex. So answer is sin x upon cos is tan x minus tan e raised to x, okay, into multiplied by e raised to x. So this is the answer for this question number 5, log cos ex. So now we do the question number 6. Differentiate this function with respect to x. So we do the differentiation of this function with respect to x. E raised to x becomes, you see that here. Let me write down the function. The function will be equal to better. We have a 5 terms are there. So I will write down all the 5 terms. Okay, we will differentiate. E raised to x, differentiation is e raised to x. E raised to x square, we are doing this one differentiation, e raised to x square into 2x plus so on. The next terms will be, you can see, e raised to x cube into 3x square plus e raised to x4 into 4x cube plus e raised to x5 into 5x raised to 4. So here there is some pattern 1, 2, 3 EX square and this EX4. All right. So this is the answer basically. Now we want to do this question number 7. Want to differentiate this function with respect to x. So how can you write down this function first? You write down the simple function dy dx. We say square root. So we write the power half better. E raised to root x power half. Okay. Now we differentiate this one. We are getting half same power. You see e raised to root x power half minus 1. Say half minus 1 into. Say this part is not x. Uh, so we say that here this not the x is there. So we have to differentiate this part again. Dy dx of e raised to root x. So simplify this one. You will say that here half. Say this power becomes e raised to root x. The power becomes minus half into, if you differentiate this one, e raised to root x, it becomes out same value, e raised to root x. But since this is not x, so it is further differentiated, dy dx of root x. Okay. You see this one, this is a power minus half and this is a plus half is there. So I will combine these two terms basically. Uh, so what we are getting? The base are same. The power is here 1 and power is here minus 1. So I will combine these two terms. So we are getting e raised to root x, base is same, and their power is minus half plus 1 into differentiation of root x. This comes out half x raised to power minus half. So this will comes out, you can say 1 by 2 and 1 by 2 becomes 1 by 4. E raised to root x power half and you see this x raised to minus half is there, so I can write down here 1 upon root x. Say question is given the root form, so I will also writing the answer in a similar form. 1 by 4 e raised to root x, and we are taking the root of that part divided by root x. This will be the answer for this question is that. So now question number 8. What this question number 8 says to you? differentiation of this function log of log x, okay, where x is greater than 1. So dy dx of log x, you know very well, dy dx of log of x will be equal to, we say, 1 upon log x. Since this is a log x is there, this is not a x. So again, we have to differentiate this part. Dy dx of log x is to give us 1 upon log x into 1 upon x. So answer you can write down here 1 upon x log x. This is the answer of this question. Question number 9. Question number 9 says, we have again differentiate this function cos x upon log x. This is a quotient form, two functions, rational function you can say. And I say cos x log x, so I will apply here the again. You remember the formula, that dy dx of quotient formula, u by v. That will be, uv minus uv upon v square. U dash v minus uv dash upon v square. Apply this formula. What we are getting, cos x, differentiation of cos x will be, minus of sin x multiplied by denominator v log x minus cos x, and differentiation of this log x function, that comes out 1 upon x whole divided by this log x function whole square. So this is the answer basically. Or you want to simplify this one, there's no need to simplify too much, because it will not change the things. So this will be the answer of this question. Now we want to do this question number 10. Right. Cos of log x plus e raised to x, where x is greater than 0. Differentiation of this part. We know cos x, log x, and e raised to x. We know the formula there. So first of all, we know all the formulas. I thought you remember the formulas, but still, we say that dy dx of this part, dy dx of cos log x plus e raised to x, okay, will be equal to what? Minus sine log x plus e raised to x. But you see this angle, this x is not, this is not the x, this is the log x function. So we have to differentiate this part. So dy dx of this part, log x plus e raised to x. So in the next line we write down minus sine log x plus e raised to x into differentiation of this part. We say log x will be 1 upon x and ex will remain as ex. Okay. Further simplifications not required. That will be end of this, you can say,